Welcome to Ask and Learn.
All right. So for this problem, we have the LRC series circuit, and we know the capacitance, we know inductance, and also we know the resistance. So we also know the amplitude of the source is 15 watts. And for part A, so we want to find out under what circumstances is the average power delivered to the circuit equal to half of VRMS times IRMS. Okay, so because we have this half in front of the VRMS times RMS, so we know cosine phi, which is the power factor, equal to half. All right, and power factor also equal to R over Z. So we can solve for Z in this case should be equal to 150 ohms. All right. And then we should solve for the angular frequencies to reach this impedance for the circuit. We know the definition of Z is square root R squared plus omega L minus 1 over omega C squared. So this is Z, which equal to 150 in this problem. And in this expression, we already know R, which is 75 ohms. And we know L and C also is right here. So the only unknown variable is the omega. So we can solve this omega by solving this equation. And the values I found for omega, so there are two possible values. So the first one is 2781 rad per second. The second one is 28762 rad per second. So we can see that there are two possible frequencies, a lower one and a higher one. Both of them could reach that Z equal to 150 for this problem. Ohms. So, but there are, of course, there are differences for these two circumstances. For the first one, actually, we can see that the reactance of C is actually greater than the reactance of L. So in that case, this the phase factor for this problem should be equal to let me see, should be equal to negative 60 degrees. But for this case, the reactance of L is greater than the reactance of C. So the phase factor for this case equal to 60 degrees. Okay. But both of them could have half factor in front of this V times I. And for part B, so under the conditions of part A, what is the average power delivered to each circuit element? And what is the maximum current through the capacitor? So because we already have Z in the part A, which equal to 150 ohms, right? So we can figure out IRMS directly by using VRMS divided by Z. And we already know the amplitude of the voltage, which is 15. So this value should be 15 divided by square root 2, okay? Because this is RMS value, and divided by 150, which equal to 0.1 over square root 2 amperes. And the power in this case, so the power delivered on the resistor would be PR equal to half So actually PR, I mean the power delivered on the resistor is also equal to the total power, because the capacitor and the inductor, they do not consume the power. So this is just equal to the P, which is simply equal to half V RMS times I RMS. And if you plug in the value for VRMS, which is 15 over square root 2, right here, you'll see the final result is 0.375 volts. And of course, PC equal to PL equal to 0, because they do not consume power. And what is the maximum current through the capacitor? We already have the RMS current in the circuit, which is 0.1 over square root 2. So the maximum current is simply equal to 0.1 amperes.